Yeah, right. So we have experiment number 4, this number 4, number 3. Okay, so number 3, called VT curve, both time curve. Last two experiment, we have discussed or found the breakdown voltage in sphere gap, rod gaps, and insulators. But in real thing, we need for breakdown to happen, we need three things. First, enough voltage. Low voltage will not break if you make it very low voltage or low voltage. If you stay for 1 year, it will not break. So we have to have error. Also, we have to have enough time. Anything in this life takes time. Maybe nanosecond or millions of years. So anyway, time is there. Time here, we are talking about microsecond. And also the third thing in gases, you need free electrons. Maybe we discussed last time in the class here. A free electron is very important or very necessary to start. Free electron is available everywhere because it's cosmic ray and light and heat. So many sources in nature which has. But sometimes in dark area you don't have this free electron. So in AC, of course, we are dealing with milliseconds. Cycles are calculated in milliseconds. Not an issue. So the time of breakdown in AC is not an issue because it happens in microseconds, so it does not matter because we are dealing with milliseconds. But impulse, we have to take time into consideration when we are designing our high voltage system, operation of the high voltage system, and stuff. So if you remember the impulse we discussed last experiment, it will go up and then go down. It will go around in the peak is about 1.2 microseconds. Generally speaking, when volt increase, breakdown time will decrease, which is normal. If you are putting more pressure in something, it will act in shorter time in everything. So this is the time. So if you have, we can have, this is, for example, this is the impulse. We apply the same shape, like the peak value is the same, 1 microsecond. So we apply 1, 2, 3, 4, 5, 6, 7, 8. The same wave shape, lightning impulse, which is 1.2 microsecond the peak. Voltage 1, then it increases, then it increases, then it increases. For example, the first impulse is very low, there is no breakdown. The first impulse, there is no breakdown. The second impulse, it will break down in the tail. When I go up peak and then go down, it will, actually the breakdown starts in the peak, but it takes long time. So the point here is T1, the first point in the VT curve, and V1 is the second point, which is the peak value. So this is the second one. This is the second point. Now we increase it further, we will have breakdown in the peak, right in the peak. So it will be second point, T2 and V2. And then we'll go to third one. We increase the voltage further, so we'll have fourth point in the front. This is the front and this is the tail. And we increase further, it will be this and this. So if you see it here, this is 4, 3, 2, 1 point. Of course, it will go steady state, of course, AC. You increase it for a long time, it will come to AC breakdown. So you remember in the last experiment, we measure V50 for impulse and AC, and V impulse more than about 20% to 25% more than AC. So this is how we obtain. Before the digital area, we have to make photo in the oscilloscope, capture the photo, amplify it, analysis, and then draw the curve manually. But now you have just to take voltage, kilovolt, and time. There is in the system there is of course peak voltmeter. You saw it last time, and there is time to break down. Time is there because the time to break down voltage. Oh, time to break down. So you will measure here, whatever, 56, for example, 55, 1.5, 60, 1.2, 70, 0.9, so on and so on. So you just take the reading and then you draw it in yourself. So why we need what is, before we discuss why we need it, VT depends on what? Depends on two things. In geometry, so for example, if you have the things which we studied first experiment, we have sphere to sphere, the VT will be like that. For rod to plane, the VT will be like that. So all of them, when the voltage increase, time decrease. But how it decrease, it will depend on the voltage. Is it bushing? Is it rod gap? Is it transmission line to ground? Is it across insulator? So every geometry will have different VT. So now, why we need VT? Basically we need it for high voltage protection. حماية من high voltage. طبعا if you know, like for example, you study in 340 high voltage protection. So assume we have this system. This is a transformer, for example. Transformer can take مثلا AC, let's say AC 33 kV. So according to standard, it has to take BIL 170 kV. So in a standard, they say when you have 33 kV distribution transformer, can take up to 170 kilovolt impulse. If it is less, and you have to test it before you use it in the system, on 170 kilovolt impulse and 33 kV. But assume that this is an AC system and there is impulse, for example, coming is, for example, 300. So if it comes to the transformer, it will damage it. So you will put in parallel with it. As you study in 340, high voltage protection, you put it in parallel. Current and protection, you make it in series. This is the difference. There is two difference between current protection and voltage protection. Current protection, you are protecting. I can raise this one. Current protection, you have circuit breaker or fuse, and this is your load. So there is two differences basically. The first difference is this is series connection, the protection in series, here the protection in parallel. And also, this device will not protect the load. This device will protect the wire. Because the load is variable, you don't know what is the load. But the wire, if the current is very high, it will damage the wire. So you protect the wire. Like at home, when you put large load in outlet in the home, if it is designed for 30 ampere and you put 100 ampere, of course, circuit breaker will work. Otherwise, the wire will get fired. Here is different, Here we are protecting the device. So this is the protected. Right. So the protective device number one, al-hami, al-hami, and then the protected device, al-mah. كلها صفات. هذه الصفة، هذه صفة بالإنجليزي، ولكن هذه صفة الحامل وهذا المرض. Okay. So we should put it in parallel. So this guy, for example, this will take 170. So I will make this work around 140 kV. So anything more than 140, it should come here and go to the ground instead. Of course, you will not put, if you have 33 kV, you will not put 40 or 50 kV. يعني تصير sensitive. Any small transient will cut it. No, you have to be in middle. You have to have some range, 30 kV, 40 kV, 25 kV, just to make sure, because this is, as we did last time, statistical. This well may be between 130 to 150, so you design it to 140. Okay, so this is how the protection device, we have two types basically. We have only two types. Either road gaps, يعني road to road، يعني بشكل بسيط، يعني road to road، road to road، بينهم distance D. طبعا ال voltage breakdown voltage, as we saw in experiment number 1, it's a proportional. For sphere it is proportional, linear. لكن for roads we can say it's not proportional, but it is function. The difference between proportional and function. Function يعني البريك داون تعتمد على الدين، ما هي تتغير خطيا مادي، تتغير مادي. So this is the first device. The second device is surgery. I just wait for the surgery just to explain. So in this experiment we will have road. In this experiment we have road to road, and we'll change the roads. We have D1, D2, D3. Of course, you will understand D1 is more than D2, more than D3. How do I know? Of course, D1 has more breakdown voltage. We will put this road gap across bushing. البوشنج اللي هي العازل اللي يودي بين الهاي فولتج. يعني I want to continue the بدون نقطع الفيديو لأنه just small things left. Okay, so this is transformer and this is bushing. Bushing طبعا it is the one who connects the high voltage to the winding inside. Of course, it has D winding. So this will, we will simulate if there is surge here come, it will, if there is a protection here, it will protect. If there is high voltage, then there will be spark here, and this spark also it might maybe go to a transformer also. So we'll put a road to road in parallel with the bushing. العرب البوشنج يسمونه جلبة. This is, of course, as we discussed before, the VT curve will be, because this is the same road gap, so the VT curve is the same. But for the bushing, the VT curve will be something like this. This is bushing. Okay. So bushing now, if we can see that D1, if the, for example, we assume, just assume this is, for example, 18 centi, it will not protect the transformer at all. It will not protect the bushing. For example, we have 12 centi. This one will protect the transformer all the time, because any time, any voltage, this one will protect. But if you have, for example, 15 centi, sometime we'll have breakdown voltage. Sometime the bushing will break down. Sometime the roads. So this is called partial protection. طبعا real life does not work. We don't want partial protection. We have to make sure there is a protection. So we have to use this one. So as we know now, it's very simple. The circuit will be impulse, as we discussed last time, you know, impulse. This is DC, for example. So we connect it to road, or we connect it to bushing. So we connected to road D1, D2, D3, and we connect it to bushing, and we'll find VT curve for 4 VT curve, 4 VT curves. And the last thing we want to connect together, then we will connect together. Then you will have, in this case, you will put table V, T, and which breakdown. For example, whatever, this is road, for example, pushing, whatever, road. So you will write 3 things. What is the voltage? What is the time, breakdown time? What is breakdown voltage, breakdown time, and usage charge? And very interesting, people who say, I mean, this is statistical, you will find sometime this breakdown, sometime this breakdown, so you know it is. So we put it in an experiment in front of you that different voltage will break it down. One of them will break the road, one of them break the bushing. The last thing we want to discuss is surge arrestor. What is surge arrestor? Of course, problem with roads. There is a problem with roads. Problems. طبعا good things about road. I think it has good and bad. Simple, cheap. Problem sensitive, حساس to pressure, change the pressure during the رياح, whatever, in the daily life, temperature, humidity, whatever was pollution, and the most important distance. Because in real life there is so much wind. Somebody hit the road gaps for any reason. So you change the D, you cannot go and inspect D every time. So this D will, any change in D, increasing or decreasing, will have problem. Surge arrestor, of course. What is good هنا, it's bad هنا. No, it's expensive and complicated, but it's not sensitive to all of these. What is surge arrestor is a very simple idea. The new one, the old one I will not discuss. The new one is just non-linear resistance. They called it photoresistance or photoresistance, I forget the name. Anyway, you know non-linear resistance, you study resistance depends on function of, for example, of temperature, function of light, photo, many things nowadays. Non-linear material as a function. The resistance will change really with photo. It will change with voltage. It will change with current. Whatever. So we will choose this one as a function of voltage. There is special material, you know, these people who study material, they test many materials, and they found that some material will change linearly or non-linearly. For us, it's not important linearly this time. So what is here? The current will be A multiplied by V or N. N now, it is this is constant, of course. It depends on the material, each material, and also constant. Also depend on the material. Now in the research, they want to increase N. So N, for example, now reach 50. I mean, even my search is about 5-6 years. I don't know, maybe it's more than now. But anyway, so assume for example, in 30 kV, current will be 1 picoampere in 1 × 10⁻12. And how about if we have, for example, 180 kV impulse, I would say 150, and it will corresponding to what we'll say 150. What is the current? Assume N is 50. So the current in this case will be, of course, 1 microampere, nano picoampere, multiplied by, of course, the first current, this is 1, corresponding to 30 pico. So what is the current? I1, I2, 150. So it's very simple that I2 will be 1 multiplied by 10⁻12 multiplied by 150 divided by 30 multiplied by 2 the us 20, 50. So what is happening is, if you calculate it at home, 10⁻12 multiplied by, this will become 5⁻50. Yeah, you multiply 50 times. It will be very, very huge numbers. So in this case, if you draw the current, here for example, this is operating voltage, 30 kV, will be almost 0. Then increase, will be like that. For example, this is 150. Of course, the resistance will be opposite. So the resistance will be infinite and will become almost 0. This is R as a function of voltage. So this is the principle of surge resistors. The problem sometimes in surge resistors, it will damage. I remember we have some studies or some investigation in the south region, because they have a lot of lightning, and there is a lot of transformer failing, and we found that the surge resistance is so many flashy every year, so they get damaged. So we have to make sure that the surge resistance be rated very high, can take not just 1 kiloampere, can take 5, 10. As you increase the ampere, of course, better, it will cost you more, but you have to balance. So our experiment is very simple. This is the last point. Our experiment for this, just we apply, this is V input. V input, we have V and we put just load, and there is nothing, open circuit. We have voltmeters. Of course, a voltmeter will have open circuit. And there is switch, and there is surge resistor. This is the output, and there is the input. So the input, for example, if there is no surge resistor, it will be like that. Because you put the input, it will go. But if you have surge resistor, will be something like certain point, start to have a smooth. Okay. So when it starts working around here, so maybe the question is, what is the working, when it will work, for example, this starting point is V out. So this is no arrestor, and this is with arrestor. Okay. So this is, by the way, one of the disadvantages of road, road, if you have road, the voltage will collapse. I explained to you last time, maybe you don't like it. So this voltage will go to zero in very short time, and this creates problems. So di and dt, and the current, the voltage across winding, will be C di على dt. This will create a lot of transient, very high voltage. This will maybe damage. So this is bad. Here, the things is very smooth. It will start cutting slowly. So this is the experiment. I want you to read. Last time, unfortunately, most of them you don't read. Please read it, because we receive them from university that you should minimize staying a student here. So read it. I will here just explain the procedure for the experiment very briefly and answer your question. So either you want at least bring one question. If you didn't bring any question, I'll put a -1 in this data sheet. Everybody should good question. Okay. Thank you very much. Yeah, nice.